Hi. If you ever wonder what are your odds of winning a game of poker? Well, allow me to go ahead and show you some numbers. My name is Brian Powell. I'm in the Math-32 class, Statistics, Discussion 12D, part of the fall 2020 semester, of course. And today, I'm going to be showing you the probabilities of getting different hands in a poker game. There it goes. So, for those of you who don't know, poker is a fun little family game. There's a picture of me with my family here. And the rules are pretty simple. You have 2 cards dealt out at each round, and there are 3 cards put face down on the table for everyone to see. As the cards get flipped over, you either raise or set your bet depending on what you think your odds are of getting a good hand. If you have the best hand, you end up winning the game, and you take the chips for yourself. So what exactly are all of these possible hands that you can get? There are 10 in specific, ranked from 1 to 10, 10 or 1 being the best hand and the rarest hand, and 10 being the most common and the worst hand, with the order being royal flush, straight flush, 4 of a kind, full house, flush, straight, 3 of a kind, 2 pairs, 1 pair, and a high card. As you can see on the right, those are all of the probabilities of getting each of those cards. And now I'm going to show you the math on how those probabilities were found. For the royal flush, it's pretty straightforward. You just divide by the number of possible royal flush combinations you can get by the number of possible hands. Now, for any poker game, the number of possible hands you can get, based off of my own research, as in playing 2.6 million poker games. Kidding. It's just from looking it up online. But the number of possible hands you can get is 2.598, or 2,598,960 hands. Of those games, you can only get 4 different royal flushes. Because of that, when you divide 4 by 2.6 million, you end up getting a total probability of 0.0000015%. So really small odds of getting it, but if you get it, you for sure win the game. The second best is the straight flush, where you have 5 cards in sequential order of the same house. To find this, or to find the number of combinations for this and every other rank, we're going to use the combination notation, as in, like in this case, 9 different combinations of 4, choose 1. That gives us 9 times 4, which gives us 36. That's the number of possible straight flush combinations. We divide that by 2.6 million total number of possible hands, and that gives us a probability of 0.0000014% of getting a straight flush. The third rank is 4 of a kind. We have 4 cards of the same kind, or 4 of the same cards of different houses, but they're the same kind of card. The number of combinations you get of this is 624. Divided by 2.6 million gives you 0.00024%. As you can see, as we're going up higher in the ranks, the probability is also going higher, which means it's just easier to get that card, or get that hand. Number 4 is the full house. That's where you have 3 of the same card and 2 of the same card. You can get 3,744 different combinations of this based off of the combination equation there. Divide that by 2.6 million, and you get 0.00144%. Number 5, halfway there, is the flush. Flushes are found by having 5 cards of the same house. The total number of combinations you can get of this is 5,108, almost double that of the full house, give or take. And as you can see, it has its effect by giving you a probability of 0.00196%. 6 is straight, where you have the same thing as sequential from earlier, rank 2, but instead it doesn't matter what house you have. The total number of combinations you can get of this is 10,240. Divide that by 2.6 million total number of possible hands, and you get 0.00394% probability of getting a straight. Number 7 is 3 of a kind. You have 55,000 different combinations of getting 3 of a kind, where it's 3 cards of the same kind. Divide that by 2.6 million different combinations, and you get 0.021%. Number 8, 2 pairs of the same card. This is found to be about 123,000 combinations of different 2-pair hands, which gives you a probability of 0.0475. Number 9 is only getting 1 pair of the same card. You can have about 1.1 million combinations of the same card, or of a pair, which gives you 0.42% probability. Number 10 is a high card, where you get none of these previous hands, which gives you about 1.3 million different combinations, which gives you a probability of 0.51%. With that said, that's my whole presentation. Thank you for listening, and have a good day.